Okay, so now we're going to look at how to solve a percent composition problem. We are looking at part 7 here. So we've got part 7, and we're going to try to figure out how to do first a percent composition and then kind of go the other way to figure out how many grams we have in a sample. So looking at part 7, we're going to start with number 1 here. We want to find the percent composition of potassium nitrate. Now, if you read what I wrote for you before above it, basically what you're going to do is to define the percent element of the compound, you're going to take the molar mass of that element divided by the molar mass of the compound times 100. Okay? So the first thing we need to do for KNO3 for number 1 here is we need to find its molar mass. So to do that, 1 potassium, 1 nitrogen, 3 oxygens. So potassium is 39.10, nitrogen is 14.01, oxygen is 16, so we're going to multiply oxygen times 3. So that molar mass should work out to be about 101.11 grams per mole. The next thing we're going to do then is start kind of breaking it down by element. So we're going to start with the percent of potassium. Doesn't matter what order you start in. I'm just going to start at the beginning. The molar mass of potassium is 39.10 grams per mole. We're going to divide that by the total molar mass, which is at 101.11, and we're going to multiply by 100. So if we go ahead and do that, we're looking at 38.7%. Okay. Then we're going to look at the percent of nitrogen. So percent nitrogen, we're going to do the same type of thing. We're going to take 14.01 grams per mole, divide it by the 101.11 grams per mole, times 100. If we go ahead and do that, we're looking at 13.9% nitrogen. Then the final step we want to do here is find percent oxygen. So if we go ahead and try to figure out the percent oxygen, this is going to be a little different. That's because we have 3 times 16 grams per mole on the top, which is going to be 48 up here because we've got this 3 right here. We're going to still divide it by the 101.11 grams per mole, which is that total molar mass we use for everything here. Okay, if we multiply by 100 then, we are looking at a percent oxygen of about 47.5%. To double check, you can go ahead and add these up, and they should be right around 100. They could be a little higher, a little lower, depending on how you multiplied them, or how you rounded them, but either way, they should be pretty close. So we're just going to do it at the same time. We're going to look at number 2 now. So number 2 is kind of piggybacking off of number 1. If you had 25 grams of KNO3, which is potassium nitrate, how many grams of each element would you have? So we're going to use these percentages that we just figured out in the first problem here, and we're going to try to use these to solve a different type of problem. So if we look at these 3%, these are going to be important to us, but we do need to make sure that these go back in decimal form, so they can't be in percent form. So when we go ahead to use these, we just want to kind of convert these back. So I'm just going to make this be 0.387. Instead of 38.7, this should be 0.139, and this should be 0.475. Okay, so for number 2 now, we will use these numbers we just converted, and we're going to multiply by the total sample we have. So we have 25 grams. So if I want to know how much potassium I have, I'm going to take this number right here. So I'm going to take the 0.387, and I'm going to multiply it by the 25 grams, which is how much our sample is. That tells me that this much, so this ratio, almost 0.4 of what I have should be from potassium. So if I go ahead and multiply that, we're looking at 9.68 grams. Then we've got nitrogen. We're going to do the same type of thing. We're going to take the 0.139, multiply by 25 grams. Okay, so if we go ahead and do that, we're looking at 3.48 grams. And then oxygen, we have 0.475 times the 25 grams again. We are looking at a sample of about 11.88 grams of oxygen. And that's all you need to do for these types of problems.